All right, guys, and welcome back. Today we're going to be talking about weight-based dosing and pediatric dosing. So Susie is a 5-year-old female. Her doctor has ordered her to get 15 milligrams of Tylenol for every 8 hours of the day. This medicine comes in a liquid that has 32 milligrams of Tylenol in it for every 1 milliliter of solution that she takes. Anyways, if Susie weighs 66 pounds, how much Tylenol will she get per dose? So right away, this question is assuming that you're going to put your answer in the best possible units. Because you could say, well, she's getting 15 milligrams per kilogram every dose. Bam, problem solved. Well, no, that's not what they're asking you to do. Right? They want to know when you go by the bedside that Susie is going to be getting that 15 milligrams per kilogram, right? What does that look like? Do you have to give her 5 pills? Do you have to give her 5 milliliters? Do you have to have a scale and weigh 10 grams? I mean, what the heck are you doing here, right? And that is what they want to know, is that you are able to figure out how on earth you're going to make sure that Susie is getting the medicine that she needs. So the first step is to define your problem. Okay, what do we need to know? Well, we don't care what her name is. We don't care how old she is. We don't care who ordered the medication, right? But we do care that she is getting 15 milligrams of Tylenol for every kilogram that she weighs, right? That is her dose, right? And so here it is in fraction form, right? So we got 15 milligrams over 1 kilogram equals 1 dose. Now, we could put this in a fraction in a one more way. All right, so you could say 15 milligrams is equal to 1 kilogram times 1 dose, right? So it's going to be very important to be able to understand kind of how you're going to change these what are equal to what statements into this over here, kind of a fraction form, right? But basically, if you replace the equal sign with the divided by sign, right? As long as this is equal to this, you've actually created nothing more than a fancy 1, right? If I write out the word 7, S-E-V-E-N, divide that by the number 7, it's going to be a 1. And this is going to be helpful because it doesn't matter how many times you multiply or divide by 1, you haven't changed what you have. Anyways, we're going to keep moving on. So Susie, she's getting Tylenol every 8 hours, right? Now, if the question's asking how much Tylenol she's getting per day, I absolutely care about that. But if the question's asking how much Tylenol she's getting per dose, I could care less. I don't care if she's getting this medicine every hour. That's not going to affect how much medicine I'm giving her per dose. Okay, so this medicine comes in a liquid. Okay, so if this medicine's coming in a liquid, my answer had better be in milliliters, liters, gallons, ounces, something that measures volume. All right, and that this liquid has 32 milligrams of Tylenol in it for every milliliter of solution, right? So for every milliliter of liquid that this medicine has, it's going to have 32 milligrams of Tylenol in it. Now, Susie weighs 66 pounds. How much Tylenol will she get per dose? All right. So kind of going over here, these are all kind of the facts that you need, right? Now, if I was trying to figure out how much medicine she's getting per day, yes, I would care about that, right? And I would care about the fact that 24 hours in a day. But if I don't care about that, right? If I'm not trying to figure out how much medicine she's getting per day, then I don't care, right? This is a bunch of fluff. I don't need it. It's not going to help me. Now, almost everything that I need was in this problem, with the exception of there's 2.2 pounds is equal to 1 kilogram. That's just something that you're going to have to know, right? All right. So next thing we have is we've converted our what equals what, right? Our patient weighs 66 pounds equals 1 patient. I converted that into a fraction. So 66 over 1 is a fancy 1, right? That's a fraction. where what's on top is equal to what's on bottom. All right, and now we know that 1 kilogram is equal to 2.22 pounds. So I'm going to put pounds on the bottom. Why not on top? Well, if I have the same unit on different sides of the fraction line, they cross out, right? I get my marker, all gone. Pounds don't exist. They never have existed. All gone, right? And so now when you multiply fractions, you cross multiply. No, that's not how you do fractions, right? You multiply across, right? Whoever came up with cross multiplication, they did it because they hated students. They wanted to watch them suffer and get confused in math. Not really. It's meant for a very specific part of math, and that is absolutely not what we're doing here. So just pretend you've never ever heard the word cross multiply, and you go a lot further in life. Anyways, you're going to multiply across. 66 times 1 is 66. 66 what? All right, well, you don't have to guess. All right, this is going to tell you. So look, pounds all gone. The only unit I have up top is kilograms. So 66 kilograms. All right, patient 1 times 2.2 is 2.2. 2.2 was? You don't have to guess, right? The units literally tell you patients, right? So if I had 2.2 patients, on the scale that were the same size as Susie, they would weigh 66 pounds. But I only got 1 patient. I'm not interested in 2.2 patients. So how do I go from 2.2 patients down to 1 patient? I divide by 2.2. Any number divided by itself is 1. So 2.2 divided by 2.2 is 1. But what I do down bottom, I have to do up top, or else I'm going to change things, right? I don't want to change anything. I can change the window dressing. I could change what it looks like, but I don't want to change what it actually is. All right, so I divide 66 by 2.2 and I get 30 kilograms, right? So my 1 patient, Susie, weighs 30 kilograms. All right, so now what I do is I take my 30 kilogram patient, and I know they're getting 15 milligrams of medicine for every 1 kilogram they weigh for every single dose that they're getting, right? Well, now what happens? I have a kilograms above and below the fraction line, so it's going to cross out. All gone, right? And so 15 times 30 is 450. 450 what? No, you don't have to guess, right? The unit is up top, milligrams, all right? So 1 patient times 1 is 1 patient, right? Times 1 dose is 1 dose. So yeah, this patient is getting 450 milligrams for 1 dose. All right. Now the question is how are you going to get that to your patient, right? So you go to the pharmacy, they give you this liquid thing. Are you going to say, okay, let me weigh this liquid till I get 450 milligrams and I'm going to get that to the patient? Well, no, because not all of that weight is actually Tylenol, right? You're not trying to get the patient 450 milligrams of anything. No, you're trying to give them 450 milligrams of Tylenol, right? And so if I wanted to be real exact, I could say 450 milligrams of Tylenol. Okay, so now I have this solution right here, right? The thing says, look, there's a solution that has 32 milligrams of Tylenol for every 1 milliliter that it weighs. All right, and so what I'm going to do right here, I got 450 milligrams, all right, is my 1 dose, right? I already know I'm just giving it to 1 patient. So, I could have kept that on there. We deal with 1 patient. All right. So 450 milligrams per 1 patient times 1 dose times 1 milliliter over 32 milligrams, right? Wait a minute. Do I put milligrams on top, down, bottom? This tells you put them down bottom. Why? Because it's not going to cross if I put 32 up top. So I got the same unit above and below the fraction line. All gone, doesn't exist anymore, right? So I'm going to multiply straight across. 450 times 1 is 450. 450 what? No, you don't have to guess. It's going to be milliliters. Well, how do you know it's milliliters? Because if you look right here, milligrams all gone. The only unit that I have left, right, is going to be those milliliters. right? And so I'm going to just copy that across. All right. 1 times 32 is 32 watts doses. All right. And so now, well, if I want to give this patient 32 doses, I'm going to give him 450 milliliters. Well, that sounds like a great way to end up in the newspaper, right? I don't want to end up in the newspaper. I just want to give my patient 1 dose. So how to go from 32 doses to 1 dose? Any number divided by itself is 1. 32 divided by 32 is 1. 1 what? Well, what's my unit? Dose. So 1 dose. But what I do down bottom, I have to do up top. All right, so I'll take 450, divide that by 32, I get 14 watts. All right, well, what are my units? Milliliters, right? And so one of the things that's great about this math is, look, I'm just doing the same steps over and over again, right? You're not having to reinvent the wheel. It's not like, what do I do now? No, it tells you what to do. And, you know, it tells you whether or not you got the answer right? If my answer was 14, let's say 14 dose over, patient day dose grams. Okay, something's not adding up here. I've done something wrong, right? And so this is going to tell you, hey, go back, take a look at your problem, see if what you're doing makes sense. So very, very helpful tool here. And so always pay attention to those units.